Okay, so the 34th problem in the lead code is to find the first and the last position of an element in a sorted array. Okay, so here we have been given the list, and we are asked to find out if this target exists in this list. Okay, that is one thing, and we'll have to return the range basically. Like, I mean, it is sorted, but it is not a, like, it doesn't consist of the unique numbers. It has a duplicate numbers. Okay, like, I mean, here we can see 8877 and all these numbers, right? Here we are given that the target is 8, and we are supposed to return the start index of it and the end index of it. Okay, let's say if there was one more 8 here, we are supposed to return 3 comma 5. Okay, that is the start and that is the end. Okay, so that is the problem about, and if it is not found, we'll have to return a -1 and -1. Okay, that is the case here, and how to go about it, right? And we cannot use the iteration, and like, I mean, we are not supposed to go with the O of n solution or O of n square. Like, I mean, we should be, the solution should be in terms of the O of log n time complexity. Okay, and how to go about it, right? Like, we could use the binary search algorithm to find out where the element exists. Correct, I can apply the, if this is array sorted, I can apply binary search and I can identify where the element is, right? I can get the index. But now the thing is, we can get either this index or this index, or maybe some, if there is 80, right? If I might be going to that. Okay, but now what I want is, I want the left index here and the right index. Okay, initially my approach was to find out an element using the binary search and then expand it left and rightward. I had one more while loop and check if there is anything beside it. If yes, increment the left, decrement the left pointer, and similarly, if there is something in the right, increment the right pointer, right? Okay, that was my initial approach. It was, after the submission, the time complexity wise, it was not that great. It was like 45 to 50% compared to the other code submitted. Okay, that was one approach that I used. But so instead, what we can do is, instead what we can do is, we can find out, we can write it to separate function that will allow us to calculate the left and right separately. Okay, first we'll be calculating the leftmost and then we'll be calculating the rightmost. Okay, so now what is the change? Okay, so this is exactly the same as the binary search. Okay, so what is the difference is, we are, for example, here we are trying to find out the left element, right? Find left element, and we will be applying the binary search. Okay, like, we will do the binary search here, and we'll do the, I will come to this point later. Like, I mean, it looks, the formula looks different than the usual, right? This is almost the same actually. Okay, so we'll apply the binary search. Like, what does the binary search do? Whenever we encounter a, whenever we do this calculation, and if we encounter mid element as the target, right, we used to just return that mid element, mid index, correct? So that's what the binary search does. So here, what is the change is, we need to get the leftmost element, right? In the case, let's say that we, when after applying the binary search, mid points to this. Okay, mid point to this, I want the leftmost. So what we are going to do is, we'll check if there is any element that is present in the left. If yes, what we'll do is, yes, we'll be shifting our right pointer to the one index behind the mid index. So that what will happen, so let's say that after we apply the binary search, right, this will be our first search, and we'll be going to here middle element, and this will be the left, and this will be the right, correct? And when we encounter something, like, let's say that we are here. Okay, like, after we encounter mid is equal to this, we'll be shifting our pointer to this, so that we can get, we are trying to go to the leftmost as much as possible. That is it actually. So once we encounter, once we identify, once we are here, right, and there is nothing, like, I mean, the previous element is not equal to the target, it means that this is the start index, we'll be returning that. So that's what we are doing here. Similarly, similarly the case for the writing, right? To find the right, we'll apply the binary search, and then we'll try to find out the, if the target is equal to the mid or not. If it is equal, then look for the element, that is, look for the number if there is exist in the next index or not. Okay, if it exists, we'll be incrementing our left pointer, and then if in the case that if there is in the next element, right, if it is not equal to the target, we'll be just returning that returning that mid element, because that we know that that is the rightmost occurrence. Okay, and that's how we'll be getting the leftmost and rightmost. Okay, and one change here is, what I learned here is, like, let's say that mid element, right, mid is equal to this, correct? So generally what we have seen is left plus right divided by 2, right? Left plus right divided, that will give us the correct mid index also, correct? So why we need to use this is, let's say that yeah, it works actually, even though if we use left plus right divided by 2 also, right, that will all the cases will pass. But the thing here is, let's say that if the array is too huge, too large, okay, too large, and we are in the end stage, let's say that we are in the 9 and 10, okay, if I add this number, this might cause the integer overflow. Okay, like if there are two big integers, right, if you sum it up, it will go behind it, right, it might cause an integer overflow. So what we can do is, let's find out a difference between them. Okay, let's find out a difference between. Okay, so sorry, so what we'll do is, we'll find out a difference here. Actually, it will different, let's say that we are trying to find out, and it's kind of average, right? So when we are trying to, let's take an example of 8 and 10. Okay, we want to find out a mid element for 8 and 10. So first we'll identify what is the difference between it, right, in the full string. So it is like, we have something like this, okay, we have something like this, and we have to go here, correct? So what we'll do is, we know that, we can find out the difference. What is the difference, right? We'll get something as x, and we will be splitting it by 2 first. Okay, we'll be splitting it by 2, and we know what is this length and what is this length, correct? That will be the length. So instead of doing that common approach, like left plus right divided by 2, what we can do is, we know this is, we are at left here, we are right here, we can just add this part, left plus whatever that part we get, right, x divided by 2. That's what we are trying to do here. Okay, and most of the time, if it is a in a small array, right, then it shouldn't matter. But let's say that we are at the end stage, we are at this index. Okay, we are trying to find out an element, and we are at this index, and when we sum it, it might cause an integer overflow. That is the reason we are not going to use the left plus right divided by 2. Instead, we are using this one. We'll take a difference, and this will be the, let's say that the difference will be very less, right? Let's say that if we are adding the two biggest index in the given array, it will be, the difference will be 1, correct? We'll be just adding 1 to this, and we'll be dividing it by 2. Like, sorry, we'll be first dividing this by 2 because of the operator precedence, 1 divided by 2 or something. Okay, and then we'll be adding it to it. That's how we can identify the mid element. That is the one learning thing here, and rest will some modification, how we can modify the binary search algorithm to find out the leftmost and the rightmost. So to summarize, when we in the binary search operation, whenever we encounter a mid element as a target, we'll just return it, saying that search is found at this index. Okay, that's what we do. But what is the change here is, we'll have to check if the what we are looking for an element, right? If the next element, let's say that if we are trying to find out a leftmost element, and our mid element is correctly here, we need to check if there is anything behind it, I mean beside it, to the left, right, if there is anything or not. If it is there, we'll have to shift our right pointer to there. Right pointer will come here. Okay, right pointer will come here, and then the next operation will continue. Okay, that is it. Yeah, thank you.